Okay, this is the video of Cumulative Quiz number 8. This way you can just fast forward to the parts that you need, and that way it won't take, you can kind of go at your own pace. The first one, it says using the definition of the derivative, the limit, compute f prime of 3. Remember, it's the limit as h approaches 0 of f of a plus h means you fill an a plus h in everywhere there's an x, minus f of a, so essentially you have this, minus 4a squared minus 7a over h. I'm going to FOIL my a plus h squared, so it'd be 4 times a squared plus 2ah plus h squared minus 7a minus 7h minus 4a squared minus 7a over h. Just the limit is going to carry. So that's 4a squared plus 8ah plus 4h squared minus 7a minus 7h minus 4a squared minus 7a over h. Cancel, cancel. I made a mistake right there. This is plus. Cancel, cancel. So that's plus. And then you just have, I can factor an h out of what's left here, here, and here. So, and I'm going to bring my limit back. The limit is h approaches 0 of 8ah plus 4h squared minus 7h over h. And I said I was going to factor one out, but I didn't. 8a plus 4h minus 7 over h. These cancel. Now the limit is h goes to 0, means I fill in a 0 here. That's what that means. So it's just 8a minus 7, where a is 3, which is 17. I'll show you where your points came from. You got a point for filling it in correctly into the definition of the derivative. You got a point for canceling, getting to here. You got a point for factoring out your h and getting to the derivative, and you got a point for 17. If all you did was take the derivative and get 17, you got a point. Find the equation of the tangent line. I don't think a lot of people miss this one, but we'll go over it anyway, just in case. Just take the derivative, 3x squared minus 4, and then remember it's y equals blank, x minus blank plus blank. That's 1, that's negative 3. I fill in my 1, because that's x. 3 times 1 squared minus 4 is negative 1. 3, e to the anything times the derivative of anything. And then the natural log is 1 over anything times the derivative of anything. For the value, okay, this is the one that we had not really looked at. I threw it out completely. I did it out of 49 points instead of 53, so this one did not count against you at all. To find the velocity, the only way that you can find a derivative, because this is position, so I'm taking the derivative, is the slope. And if you're looking at 2, you're going to go on either side of 2. So it's like you're using the point 0, negative 5, and 4, negative 15, and you're finding the slope. Negative 15 minus negative 5 over 4 minus 0. That's negative 10 over 4. So that's at 2. And then it asked us at 12. So we're going to go on either side of 12, here and here, and we're just finding the slope. 12.5 minus negative 7.5 over 14 minus 10. That ends up being 5. 6, the one that gave everybody trouble. Alright, some tips on this one. First of all, I'm going to define this, because I'm going to have to plug stuff into this over and over again, so the best thing you can possibly do is to define it. So I'm going to go to my, well, here, I'll show you how to get there. Your regular old calculator screen, and you're going to go menu, actions, define, and I'm going to define it as its position. I'm just going to call it S of X equals parentheses x to the third plus 1 times parentheses 5 minus x minus 5. And then all you have to do is s of 0, s of 1, s of 2, and s of 4.95. So 0, 3, so 0, 3, 22, and 1.114. Find the velocity of the particle at time t. The best way to do that was to go ahead and FOIL it out. That's 5t cubed minus t to the fourth plus 5 minus 5t minus 5. The 5's actually cancel away, and you get the position is 5, well, let's put it in a nice order. Negative t to the fourth plus 5t cubed minus, that 5's not right. Sorry about that right there. 1 times t is not 5t, last time I checked. So minus t. So my velocity would have been negative 4t cubed plus 15t squared minus 1. And then you want to find at 0, 1, 2, and 4.95. Well, remember that's the derivative. Easiest way to do that on your calculator. Remember to use your calculator to the best of its ability on a calculator question. Derivative of a point, my variable is x. The first one I want to do is 0. And guess what I want to do it of? S of x. That way I'm not risking any kind of chances that I type it in wrong. And then I change my 0 to a, what am I doing next? 1. Then I go up, copy it, bring it down, change my 1 to a 2. Go up, copy it, bring it down, change my 2 to a 4.95. Work smarter, not harder. There's no sense in having to type all that in over and over and over again. Because you just don't have time to do that. That's negative 1, 10, 27, and negative 118.612. When is the particle at rest? The particle is at rest when the velocity is equal to 0. Okay, so I need to graph the velocity. I've already done that. Here, tab. I graphed my velocity, my 15x squared minus 4x cubed minus 1. Notice my window. I changed my, well, I didn't change it to that. I changed it to 0 and 4.95. Whoops. I changed it to that because if you look back, first of all, your bug can't move in negative time, so you got to throw that away, and that was several of y'all's mistakes. You have to throw away anything below 0 because we're talking about time. And then 4.95 seconds, right here. In other words, he stops moving at 4.95 seconds. You're only, basically they could have told you this. That's what they were saying for 4.95 seconds. So, and now I find my zeros. My zeros are 0, that one, and that one. Hold on, let me copy this. I'm going to paste it over here. Oops, paste. So we can see what's going on with that. I'm going to need both of these in a little bit. Alright, so this is my velocity graph. So if I do a sine graph, based on that, I've got 0, I have 4.95. My two zeros are 0.268 and 3.732. It is below the x-axis, above the x-axis, below the x-axis. So when is it moving forward? Forward in this problem equates to the right or up. That's another way that AP phrases things. When you see right, up, or forward, that's when velocity is positive. If you see left, down, backwards, that's when velocity is negative. So my particle is moving forward from 0.268 to 3.732. And I think because I wasn't sure if you knew that, somebody put all three, and I may have said that was okay, I can't remember. Find the acceleration. That was just the derivative of the velocity, and that was 30x minus 12x squared. I feel like I skipped D. I'm not sure where D went. Oh, there's D. Found it. Okay, so there's the acceleration. Total distance. Okay, I want to find the total distance traveled. Come on, 30x minus 12x squared. Move down. Close enough. From 0 to 1. So I want my position at 0. My position at 0 was 0. Okay? And then I want you to look at the path of the particle. He's moving to the left, then he's basically moving to the right, and then he's moving to the left again. So if you track the particle, he moves to the left until he gets to 0.268. If you plug 0.268 in, you get negative 0.177. Okay, so his distance that he's traveled so far is 0.177. And then at 0.268, he turns around and he goes back the other way, all the way to 1. And at 1, it was 3. So the distance between 0.177 and 3 is something, 0.177. And he goes to the left, so that's actually negative, sorry, negative point, nope, it's still 0.177, plus 3, so that's actually 3.177, so it's from negative 0.177 to 3, so you would have to do 3.177 plus 0.177 and get 3.354. And then from 1 to 2, he's moving right the entire time, so you don't have to worry about as much. His position is 3, and his position is 22. So the distance there is easy, that's just 19, so that one was bigger. And then when is the particle speeding up and slowing down? And this is where we're going to have to do, we need our velocity, we need our velocity, and we need our acceleration. I graphed my acceleration on this one. This is my acceleration. So I'm going to copy this and pull it over, paste, and bring it down. And I would graph them separately. It's very difficult when you try to graph them on the same graph because it's hard to see what's going on. So here's my velocity graph, and I'm going to overlap them. My velocity graph from 0 to 4.95, we have 0.268 and 3.732, and that's negative, positive, negative. My acceleration graph only has 1 0, and it's at 2.5, which is about, where is 2.5? 2.5 is before, no it's not, I'm just kidding, it's right here, 2.5. So that's above, below, so positive, negative. So when is it speeding up? It's speeding up where the signs are the same. So we'll do speeding up in yellow. It's speeding up here, because they're both positive, and here, they're both negative. When is it slowing down? It's slowing down when the signs are different, so there and there. And I think some of the problems here where you were including that infinity. Speeding up was 0.268 to 2.5 and 3.732 to 4.95 and to infinity. Not to infinity, that was your mistake. I was finished my thought. Speeding down. Wow, speeding down. You know what I mean. 0 to 0.268 and from 2.5 to 3.732. Oh, that was tough. This, find the value of k that makes it differentiable. Well, in order to be differentiable, it has to be continuous, so we plug in 0 to see if it is, and you get 3 equals 3, so that's no problem. Differentiable means you take the derivatives. The derivative of the top is negative 2x minus 2. The derivative of the bottom, the constant goes away, the 3, and you get negative k cosine of x. You fill in 0. You get negative 2 equals negative k times 1. Where'd my negative k go? I appear to have lost my negative k. Oh, it shouldn't be there. It's derivative of cosine. Sine is cosine. Gosh. Okay, so because cosine of 0 is 1. So it's just k equals negative 2. 8. This one you have to graph them both and see where they cross. No, I don't want to say nothing. Graph. You graph the derivatives because parallel tangent lines means derivatives. So it'd be 3e to the 2x times 2, and so 18x squared, 18x squared, and you want to know where they cross. Menu, analyze, intersection, and it's negative 0.391, which is C. 9. The inverse, remember the inverse is 1 over the derivative at the x value where f of x equals 2. So you had to do x cubed plus x equals 2. It's a cubic, so again you have to use your calculator to solve that. New document, no, I don't want to save nothing. Calculator, menu, I'm going to cheat because it's a polynomial and it's just easy to do, and I'm going to use my calculator to the best of its ability. X cubed plus x equals 2, comma x equals 1. So I want 1 over the derivative, 3x squared plus 1, at 1. So it's 1 over 3 times 1 squared plus 1, so it's 1/4. And that was just remembering the formula, and I think a lot of us have forgotten it. I would study that. That is on your test. Which of the following is false for the graph shown at the right? Well, let's go one at a time. Let me get an arrow so that we can look at this one. This was one of the most commonly missed questions. Okay, f prime of b is positive, is greater than f prime of c is negative, f prime of d is negative, is greater than a negative plus a negative. So that one's true. F prime of c is positive, is greater than f of c. Well, f of c is positive, so I'm not 100% no, I'm sorry. F prime of c is negative because the derivative is negative. F of c is positive because it's above the x-axis. So I just found the one that's false. I can keep on going so that we can look at what each one says. F prime of e, that's the slope at e. It's increasing. It's positive. Is greater than the slope between b and c. So here's this tangent, the secant line, and there's the tangent line. So e is steeper. So this is true. So it's not that one. F of a is a positive number times f prime of b is a positive number is greater than f of e is positive. F of e is positive, f prime of d is negative, is greater than a positive times a negative. That's true too. And f is increasing on from a to b. That's true too. So it was b. That's it.